Okay, you guys, you should have your iPads open. Come on, girls. Yeah, you should open up on Notability again. I can't get this to work. Okay, so what we're going to do today is we are going to look at properties of parallelograms. By the end of the lesson, you should be able to determine side and angle measurements using opposite sides and angle properties of parallelograms. That's one thing you're going to do. You're going to find angle measurements using consecutive angles. And you're going to look at a diagonals conjecture. We're going to learn about the properties of diagonals in a parallelogram. So before we go to the actual slide with the notes on it, I'm going to draw a parallelogram. Because I'd like to see you at least have some idea why things are the way they are. Not everything can I do. So I'm going to draw a parallelogram. You don't have that ability. And like I've always said before, what appears to be true generally is true if you do a nice diagram. Well, I know that these lines here are parallel. That's parallel to that one. And by the way, what is a parallelogram? Let's define that. Okay, there's a ton of vocabulary. So you need to be probably studying for that test now. Because you're going to have to know this. You're going to have to know some of the exterior angles, some of the interior angles. And if I don't I'll either put together a worksheet or we'll do something on Thursday that pulls it all together for you. But it's a quadrilateral. And what's true about the opposite sides? Both pairs of opposite sides. They're parallel. So these are parallel. And these are parallel. And because I have parallel lines, I get a lot of good stuff with it. Okay, both pairs, you have to know this, of opposite sides are parallel. Not just one pair. If you only have one pair of opposite sides parallel, what's that called? Just with a T. Trapezoid. Okay? So we have to know what these are. You may still have to go into Safari and clear all that stuff out. That's weird. You can take a piece of paper, or you could just open up Notability and take some notes. Okay. You remember what's true about parallel lines? That's right. What's true about the angles? What's true about angle 1 and 2? 1 and 2 are corresponding. Either the angles will be congruent or they're going to be supplementary. That's it. When you have parallel lines, the angles will either be the same or they're going to add to 180. Okay, Garrison? Okay, so when I do this, what's true about 1 and 2 are congruent? What about 2 and 3? They're not.
No, 2 and 3 are equal up to 180, so they're corresponding. Yeah, they're corresponding.
No, they're not corresponding. 2 and 3 are not corresponding. They're going to be supplementary. Because the measure of angle 1 plus the measure of angle 3 is how much? What do these guys form? A linear pair. So they add up to what? 180. And I know that the measure of angle 2 is equal to the measure of angle 1, right? So if I take 1 and replace it by 2, what's true about the measure of angle 2 plus the measure of angle 3? They equal 180. So when you're looking at these problems, they're either all going to be equal or they're going to add to 180. When you have parallel lines, you have parallelograms. So these angles, call that 2 and 3, those are supplementary. Well, okay, so measure of angle 2 plus the measure of angle 3 equals 180. What about 4 and 2? Because these are also parallel. Now look at the picture. 4 is obtuse, 2 is acute. It's possible they're equal, but do they have to be equal? No. Okay. So what has to be true about 2 and 4? They have to add up to 180. So the measure of angle 2 plus the measure of angle 4 has to equal 180. And what I'm going to do with these two equations, I'm going to subtract the bottom equation from the top equation. Make that minus, minus, and minus. And when I do that, what happens to the angle 2's? Measure of angle 2 minus the measure of angle 2, it gives me nothing. And 180 minus 180 gives me nothing. And so I'm going to have the measure of angle 3 minus the measure of angle 4 equals 0, which tells me that the measure of angle 3 and the measure of angle 4 are what? They're the same. So guess what? Opposite angles in a parallelogram are congruent. We're going to fill in the chart. These are, 2 and 4 are called consecutive angles, and they are supplementary. So in a parallelogram, either the angles will be equal or they're going to add to 180. Okay, guys? That's all you have to remember. Look at the picture. Do 2 and 4 look like they're the same size? Yeah. This is obtuse, so that's acute. No. How about 3 and 4? Yeah. Okay. What else is true about parallelograms? I can't prove it to you. If I draw this diagonal here, what do you think is true? Except I didn't want to do that. Wrong button. What do you think is true about my two triangles? They're congruent. Can't prove it to you yet, but they are congruent. So what do you think is going to be true about this side and this side? You guys know this. They're parallel, but they're also congruent. And what about this side and this side? They're congruent. So opposite sides are congruent. Opposite sides are parallel. My angles are either congruent or supplementary. And if I draw another diagonal in here from 3 to 4, are those diagonals congruent? No, let's pull it out. I'm not sure where I'm going to put it. Let's put it here. And let's take this one, and we're going to flip it. And I'm going to try and slide it. Now, do they look congruent? Look at this length and that length. No, they're not congruent. So, but what they are going to do is they're going to do something special. No. We'll put this one back and this one back. What do you think about these lengths? What do you think about this length and that length? They're the same. So these are equal. I'll use 3 tick marks so that I don't want to get them confused with anything else. And what about these other ones? This one equals that one. That's right. And I'll use this kind of a mark. So the diagonals, if the diagonals divide them both into 2 congruent segments, what's the word for cutting it into 2 equal pieces? They bisect each other. Okay, now all I did was draw a picture and observe angle, the angle relationships to see if they were the same or added up to 180. It proves some things to you, but you know what? If you draw a nice picture, it's what you think is true. So let's fill in the properties here. Opposite angles of a parallelogram are congruent. Now, we have to fix this because it's not right. It looks like these consecutive angles are congruent. They are not. So I'll put a double thing there and a double one there. Opposite angles are congruent. But consecutive angles are, look at them, acute and obtuse. What are they going to add up to? 180. So they're going to be supplementary. So the sum equals 180. They add up to 180. It doesn't matter. These, the blue and the green are supplementary. This blue and this blue are supplementary. And the opposite ones are congruent. Consecutive is right next door. You're consecutive to Cole. Right next door. True. Okay. How about opposite sides of a parallelogram? You know this. They're what? They are parallel. And they're congruent. Well, actually, let's write that. They're parallel and congruent. I like that because both are true. By definition, they're parallel. And what's true about the diagonals? They bisect each other. They are not congruent. They need not be. They might be congruent. That's what makes tomorrow's lesson hard. Because tomorrow we're going to talk about special parallelograms. You know them. Can you give me a parallelogram where the diagonals are congruent? When would that be? A square. There's another one. And a rectangle. Yes. One of them would work. Yeah. Hopefully there won't be any questionable things. I don't know. Okay. So tomorrow what we're going to do is I'm going to tell you I have a parallelogram, but the diagonals are congruent. What could you classify that? It's a rectangle. Might be a square. But a rectangle also works. You want the most general name you can have. Can't restrict it too much. A square is pretty restricted. All sides have to be equal. All angles have to be equal. Okay, so there we go. We have some problems to do. Find A, B, and C. Well, B is the easy one. Why is B 70? No, not supplementary. Opposite angles are congruent. Now, I can find this. If this is 70, then how big is this big angle here? Because remember, this has to add up 70 plus the green, how about we call it the green, has to equal 180. How big is that obtuse angle? My green angle is 180 minus 70 is 110. So if this big angle is 110, how big is angle C? Okay, Tess, how big is angle C? Well, you take 110, angle C, measure of angle C is equal to 110 minus 50. I know some of you don't like the vocab, but I really have to be talking on the same page. This is 70. Then this is 110. This big green angle is 110. Because these are supplementary. Then this is also 110, right? And C is 60. And we also have alternate interior angles, which is actually A isn't that hard to do because these are parallel. Guess what? These are congruent. So it's 50. Alternate interior angles. Question? There's a lot of ways to do it. I did it differently this morning, I think. So it's it could be a different problem. That might be it. But there's more than one way to do this. So that's the, I'm just showing you how I'm thinking at the moment. Never know. Okay, are we okay with these guys? The other thing is, once you knew C was 60, could you have added these all up and subtracted from 180? Sure. Because the sum of the angles of a triangle is 180 degrees. Doesn't matter. Let's use all those things. Okay, oh, this one's easier, actually. How big is B? I like to do easy first. Tess, how big is B? 118. Okay. And then what's true about B and A? Okay, so A plus B equals 180. So A plus 118, whoops, equals 180. How big is that? 62. And then A and C are equal, so those are 62. The problem is that each individual lesson isn't particularly hard, except some places are. But when you put it all together, you have to remember everything. That's when it gets to be hard. Okay, I always like to do easy first. I think Z is easy. How big is Z? Yeah, because these are opposite sides. We know they're congruent. You know that walking in here. I didn't have to teach that. Z is 14 inches. And then please include units just in case we check for units. If you're given units, you should have them. And these bisect, that's a midpoint. So X equals 9. You're right. And how about Y then? Y and 8 are the same. So that's 8 inches. The only one that requires really any work is for W. Because what's true about this side and this side? Well, that won't help you with length, though. They're parallel, but they're also congruent. So 12 equals 2W plus 2. And then we subtract 2 from both sides. So 10 equals 2W. What's W equal to? 5 inches. Questions on that? Is that okay? Is that okay, Tess? Okay. Try the next one. Give you some time to try it. A is pretty easy. And there's a variety of ways to get there. Okay, so how big is A? Yeah. And they do. If C is 60, that's 130, and that's 50. Yeah, that's good. That's why I'm walking around. So A is pretty easy. That's 62. There's a lot of ways to do this, by the way. Oh, B is easy too. How big is B? I did this the hard way earlier today. 54. Because these are alternate interiors. Okay, so this is 54. A is 62. So what are you going to do? C plus 54 plus 62 equals 180. Now, if you don't have a triangle, it's not going to be 180. If you have a quadrilateral, it's 360. If you have a pentagon, it's 540. If you have a hexagon, it's 720. We'll have to review that when we go over the worksheet. So what's C end up being? Is it 64?
Yes. So 62 minus 180 or 180. Yeah, it's 118.
Yep.
118.
So C plus 118 equals 180. Okay, is that the last one? That is the last one. So your homework, oh, I know why it's not on there. Homework is lesson 7. And you have to finish up that review sheet. If you don't do it, I think you're going to be in trouble on the test. It's the problem. Okay. The sum of the interior angles of a polygon is what? N minus 2 times 180. Do you remember the sum of the exterior angles? Always. Guys remember? That's right. These are things you have to know. Well, you got to tell them it's not working. Okay. Regular, like Zach said, means equilateral and equiangular. Okay, so let's go back and look at 27. Oops. Okay, one interior angle of a regular polygon measures 170. Okay, guys? There are a couple ways to do 27. If you haven't done it, let's do it right now. One thing I do is I draw a picture, and you might be saying, well, I don't know how many sides it has. How can I draw a picture? Well, you know, I don't know either, but I'm just going to draw a picture, and the interior angle is 170. It's regular, so all the angles are equal. I could work with the sum of the interior angles, which is harder, or I could work with the exterior angle, because the number of sides is equal to 360 divided by the measure of the exterior angle. So how big is the exterior angle? 10. So it's 360 over 10, which gives you 36 sides. Now, do you want to do it the other way, just for fun? Because that's harder. On the blue sheet? Which one? That is a regular octagon. I would again use with the exterior angle. You know what B is. Right, and all those other angles are octagons. So you either can use the S of I equals n minus 2 times 180, or you can do the exterior angles, whichever. I would do. When you have an octagon, is that an octagon? I can't draw them very well. But anyway, it's equal to 8 minus 2 times 180. And there are 8 angles. A equals whatever that is. Okay, but what about the worksheet? Because that's, so you should have the first side done, and maybe the second side. The third and the fourth, they're hard. 20 I thought was hard, because you know what? I looked at this and I said, from here up to here is a straight line. Well, it isn't. Let me show you. I drew this line right there, and is that a straight angle there? Is that a straight line? Or is there a little angle there at P? So that changes everything, and so you have a certain number of sides. This is the worksheet that was due for today. You may not have tried that. The blue one is homework, so your job is to finish this up. So there's 1, 2, 3, 4, 5 sides there. So 5 minus 2 times 180, that's the sum of the interior angles, which is 90 plus 107 plus Q plus P plus 55. I think I have to find P first. Oh, yeah, I do. You want to find all those, but you'll have to find P before you do that. So if I look here and I look at this, I know it doesn't look like an angle, but I'm gonna exaggerate it a little bit. You'll see why it doesn't look like much of an angle. This is 55, and this is 133. So what's true about, yeah. I mean, I had a real hard time seeing that angle there. But when I put the straight line in there, whoops, not 180, 360. When I put the straight line in there, then it was real clear to me that there is an angle there, It's not 180 degrees, but I think it's like 179 or something. It's pretty big. So once you find that, then you're no, get your calculators out. Plus, this is 188 equals 360. So P is equal to 172, right? So it's so big, it does look like a straight line. So P is 172. To find Q, you have to solve this equation for Q because that is a pentagon. Doesn't look like it. I thought it was a quadrilateral, but it's not. It has 5 sides. And you just have to keep working around it. By the way, if this is a right angle and this is a right angle, these lines are parallel. How big is that? S. It's an easy one. It's 90. I like to do the easy things. Okay, so once you get some of that, you're going to be okay. You'll have to figure out what R is, and then you can find T, because that's also T. So you know how big this one is. How big is that? Even though it's not labeled, we need it. It's 73, right? Is that right? So then you can find that question mark, because 73 plus the question mark plus 90, two 90s, right, has to equal, what's the sum of the angles in a quadrilateral? 360. So you find the question mark. Then when you find this question mark, you can, and you know what Q is, so we found, well, I haven't found it yet, but Q plus R plus my question mark, could have given it a name, but question mark's good, is 360. You just have to keep working around it. I think this is hard because I really had a hard time seeing that that was not a straight line. And this was the only way I could see it. See now? Not straight, is it? So what was the other one you said? 28 on this one? That's fine. You can go back. 8. Oh, okay. N and M, I want to use these are supposed to be congruent. Yeah, but you got to figure out what corresponds to what. So if I do O, N, M, Q, P. So O corresponds to, I think, T, right? Then N goes with U, M, no, I got a Q with V.
Then R goes with
What R? Oh, R goes with what?
no. Oh, here. R goes
O, N, it goes T, S. That's what it is. S, they don't really tell you. R, V, I had to get that one lined up. And then P goes with U, right? T, S, R, V, U. There we go. So now you know how big angle N is. N is the same as S. So N is 82.
I had T and N were together.
O and N. O and N and TS are the same.
How do we know it's O and N?
Because you just have to look at your length. I have to take a picture of it and line it up.
What if you go like this?
First off, this has to match with Q, doesn't it?
Yeah, but like
So once I put Q, V has to be there.
what if you rotate it?
But if you go this direction, V will not end up here. So if you go T, U, V would match up with M, and V does not match up with M. So I had to go the other way. Yeah, that's where I had to match it. Probably other ways to think about it, but that's how it works. Okay. Oh, I didn't clear the ink on this page. Are there questions on these? I can clear the ink and we can do them.
So you go back up to the over
There they are. So P goes with U. So P should be 61. The answers are online. You can check me, make sure I'm right. VR, where's VR? VR is the same as, let's see, VR as MQ. MQ is 7.2. And ON is the same as TS, so it's 16.1. That one's hard to match up because you really don't know which was long. I would like to make this side a little bit longer so it's obvious. Kind of looks like the state of Minnesota, doesn't it? Other one. Have you had a chance to do the next page? If you haven't, I don't want to go over it yet. I can save that. I don't know if you tried those. Yes, I am going to clear the ink. There we go. Now, these are mid-segments. So this is a midpoint here. So how big is this side? The midpoint, so it's 16. So the whole length is 32. How about X? X is 21. It's a midpoint. And Y has to be half of that, which is 7. How about 15? Is that okay? Because these are midpoints, this is half of that. That's that mid-segment there. I don't remember teaching it, but I know it. They did tell us that. And I know I want to say A and C are 90 degrees. They're really close to 90 degrees. Maybe 91. One's 91, the other one's supplementary. A and C are supplementary because these are parallel because you're joining the midpoints. How big is B? If this is 54, how big is B? Because these are parallel. 54. And you can find A because A plus 54 plus 37 equals 180. So once you find A, you can do that. And there's a variety of ways to find C. After today, we know that A plus C have to add up to 180, because we just did that today. Or you could find this angle here, and then C and that little red angle form a linear pair. Subtract from 180. You're going to get the same answer. Or, I forgot about this old theorem. What else is true about the measure of angle C? The measure of this exterior angle is the sum of those two remote interiors. So it's 54 plus 37. That's even easier. That's 91. And A and C are supplementary, so I know it's going to be 89. So I've solved that problem today now, like 3 different ways. It doesn't, but this is a mid-segment, and if you join the midpoints, this will be parallel. I don't know if that's somewhere in our theorems. The problem is we don't have any proof for anything, so if you build it up with proof, it's a lot easier. How about 17? You know how to do 17? Well, the hard part is finding X. Y is 11, that's easy. Z is halfway, so that's 6.5. Now, this mid-segment is half of the sum of the two bases. It's an average. So 29 is equal to 1/2 of X plus 41. So how do you solve for X? Well, I don't like that half in there. So what I'm going to do is double both sides. Because then on the left side, I get 58. Because I've done 2 times 29 too many times in my life. And what happens to 2 times a half? Cancels out. That's the reason why I chose to. I could have done 4 if I wanted. Equals X plus 41. And now that's easy to solve. We subtract 41. I always try to get rid of fractions if I can. So that's going to be, what, 17? These are tricky. I don't think these are easy, 18 and 19, any of those problems. But I want you to try them. You can use exterior angles in particular. On number 23, I'm going to use the exterior angles. If I add up the exterior angles, x plus 2x plus 3x plus 72 plus, I'll have to find that one, and I'll have to find that one. I'll put 2 question marks. That equals 360, and then you can solve for x. They're not easy. And when I look at them, if I haven't looked at them before, that makes me kind of nervous. So I imagine it makes you nervous. No? Or do you like it? Because they're puzzles. These are equilateral. These are regular polygons, so that one's really not bad at all. And what do you think about the measure of this angle? Is it obtuse or acute? Look at the picture. It's obtuse. It's a pentagon. So you know it's got to be bigger than 90. It's going to be 108. But you can find them. B is an angle. I need the angle. And A is an angle. Yes. So the sum of the interior angles is 5 minus 2 times 180. Or you could do the exterior angle and then find the interior angle. Just subtract from 180. Pretty much everything's going to be congruent. You subtract from 180. I see 180 a lot. You've noticed I've said that number a lot today. Well, no, because the sum of the angles of a triangle is 180 degrees. That's really what it comes down to. So if you're struggling, plan on coming in Thursday morning. I might be available tomorrow, but I'm thinking I'm going to have a parent conference tomorrow, so I don't know.
Wait, this is beyond number 20.